lab and STEP. And this morning I was testing again about teacher education.
About teacher education?
Yes.
Yo, Alexander, I'm a postdoc at Dave's team, and a lot of the time this week was spent on reviewing papers from the Learning Analytics conference. It's talking to be very much relevant to this area. So, expecting to see.
My name is Stephen Lam. I'm a lecturer in physics. I'm previously worked for the Institute. This week I have 3 groups. I work with physics faculty 3 groups and very, very forums. This week I'm preparing for video projects.
I'm Dave Pritchard, and I actually do a little bit myself, although these guys do a lot more. I've been thinking a little bit, well, I've been doing some problems, some concept problems for 8421, the graduate physics course. But I've also been trying to rework ideas of putting standard assessments. There are a lot of discipline-based assessments and standard, more general assessments, like about you understand how to use graphs, you know, loss and test of scientific reasoning. A whole series of these things. They don't get used very much. And the result is that we pretty much free float in that all the college instruction, there's no standard. And if it were, I think that people could tell when they improved it, and they could point to their department head to show that they improved it, and then hopefully the department head would require that the next professor who took it over at least equal the results of the previous one, instead of just completely redoing it however he or she thinks is best, which is what happens.
So hi, I'm Elizabeth, and I'm from the Oxford Education Society, and I've been following up on last week's Charles River Acts about blossoms, and putting together a list of people I know in the UK who I think would really love to make fuller use of blossoms, right? STEM teaching, high school lessons, wonderful stuff. And maybe even contribute some lessons themselves. So.
Well, you'll all learn more about Mr. Bremer Vipal, Vice Provost of Advanced Learning. That's Harvard's online education equivalent of ODL. So I'm a part of the Vipal research team. I'm a research fellow. And what I work on is a overlap sort of representative, but basically how do we redesign, take any technology, whether it's an on-campus course or an email sending out, and redesign it to be adaptive so that we can actually have scientists collaborate with teachers on improving it. And one thing I did this week, of course, was putting all this work together because most of it's pretty new. But another thing is writing a report on engagement for Harvard X. So basically, they wanted to see a bit of a review of what engagement measures are out there and how they might conceptualize engagement in books.
I'm Neil Lepper. I'm a professor at Worcester Polytechnic Institute, and I'm the computer science professor and the director of the PhD program in Learning Science and Technology. I do a lot of grant funded work actually related to the platform I built called Assistance, which you'll hear about at the end of this talk. One thing I did this week is actually working on helping pre-service teachers, that is actually elementary, middle school math teachers, learn to write explanations and record them. But we're not talking courses, or we're talking not blossoms, which is long videos, 10-second, 12-second, 20-second, actually YouTube recorded sort of like explanations, and crowdsourcing those from actually, honest about pre-service teachers learning this task, so they learn to actually get feedback from their instructors, but then actually hopefully the stuff that actually is good, we crowdsource and actually give to 50,000 kids that use our website.
I'm Susan Hargrave. I recently retired from the Massachusetts Department of Common Contemporary Education, where I the Office of Digital Learning. So I'm exploring how I might kind of connect with the field. I'd say I've actually accomplish anything this week other than to learn it out this group.
I'm Sophia Gatos. I'm a project lead at HarvardX, and this week I've spent a lot of time working on writing some learning objectives for a cell biology course focused on the mitochondria.
Is that cell biology course biochem or it's a new course?
No, it's a new course. This is Robert's course.
Got it, okay. And just one thing, so the course that Sophia is actually not, one of many things she's doing was actually a course that I embedded some of these MOOClets into when someone else was doing it. So you might have seen them pop up. One thing I just mentioned here was I'm originally from Trinidad and Tobago in the Caribbean. That's why I have this strange accent. And I'm telling you because often people are confused and they say they missed the first part of the talk trying to figure out where I'm from. But now I know I'm from Trinidad, I have your full attention. So in this talk, I'm basically going to talk about a framework that I've developed over the last couple of years, really only reached its full maturity in the last couple of months. That's basically trying to solve a problem that I've had in the last 3 years, and I think that all of you have had, which is, if you just give me any educational technology, how do we design it so that it's adaptive? And by adaptive, I mean a couple of things. One is it changes in response to an individual learner, but I actually am more interested in adaptive over time. So this is an intelligent technology in the sense that what you show in year 1 versus year 2, like Dave mentioned, that needs to get better. And it's also adaptive in the sense that it should give different students different versions of experience. And for me as a scientist, the key challenge has been how do we do this in a way that we can bring together engineering teachers or platform designers and actually researchers. Because in my experience, having had to run studies and experiments, like embedded them in Khan Academy, in assessments, in edX, in Novoed, in Coursera, in Moodle, in Canvas, these challenges crop up all over the place. And so this is kind of an attempt to synthesize a design that I think will help alleviate a lot of those problems. And it's really, the users of this framework are really instructors, they're engineers, and then they're psychological researchers who do randomized experiments, they're educational researchers who do experiments, and they're also machine learning researchers who want to actually use algorithms to automatically experiment and automatically personalize. Yeah.
I think we should say that, I think we're recording this talk.
Yes.
Okay, so in case you didn't know, we're recording on that.
Exactly. I'm just using.
So
yeah.
Let you know we're doing
Thank
it
you.
for other people to be able to actually see it later.
And this would be great if it's easy to do for the talks weekly. Honestly, it's just like opening a Google Hangout on AI. I can send an instruction to someone, and it basically just screencasts what you're saying and puts in a YouTube video. So it'd be great if other people are able to do this as well. And kind of showing the cross-platform nature of this, Neil's going to actually talk at the end of about 5-10 minutes about how Assessments, which is a platform that focuses on K-12, but I think has been in this game for a long time, 10 years or more, how it can actually use this approach and might be very complementary to edX and on-campus resources like Canvas. Especially on the issue of trying to bridge scientists with practical impact. Because Assessments, you may not all know it, but basically it's a lot like Khan Academy in terms of what it provides, problem sets. But I think the difference between Assessments and most platforms is it's built from the ground up to help teachers. So teachers use Assessments just because they want to have free math problems to give students. But at the same time, it's built for scientists. So scientists use Assessments for no other reason than that they can embed a randomized study in a real classroom or in real homework. So I think it's kind of hits a lot of the goals that I think I'm trying to get to, is how do we design technology that simultaneously is totally usable just practically and totally usable just scientifically. Okay, so in terms of an overview, I'll present a bit about what I mean when I say we can take any online education resource and just, what do you get if you turn this into this component I call a MOOClet. MOOClet is just a name to let you know there's a well-defined formalism behind it. There's a set of if and only if statements, criteria to make something a MOOClet, but you could have called it anything, and maybe you have better names. Adaptive component, special thing that lets you do cool stuff. I'll give you some examples of MOOClets. Talk a bit about how it enables experimentation and adaptive personalization within the same framework. And then actually how, just by setting up as a MOOClet, you can actually get machine learning researchers to collaborate with you to automate your improvement of instruction and your discovery how to personalize. Provide one application of learning via crowdsourced explanations, which was inspired by working with Neil because that's what his team has been redesigning Assessments to do. And then turn it over to Neil, who's going to talk about our NSF grants and activities that actually has redesigned assessments to sort of crowdsource teachers and scientists in coming up with improvements. And then close on feature directions. But really, I think feature directions are up to anyone who's listening to this. Basically, how does this enable you to do things that you thought weren't possible before that you wanted to do but want to do more easily now? Okay, so in terms of taking what the goal is the goal is to take a typical technology and make it an adaptive, intelligent micro lab. So when you look at something like edX, to me it's very hard to know, okay, if I look at this web page for this course, what of this can I change? Can I experiment by writing different explanations? Can I experiment by adding motivational messages? What's technically possible? What's the instructor interested in? And what data is going to be available? For me, it's kind of a bit of a war, whether I look at edX or Khan Academy or Sysmonths. And to do this on Khan Academy, they had to literally give me their code base, the entire code base inside to figure out what exactly could be going on. There was a lot of other help and documentation, but that gives you a sense of the way in which technology is right now a barrier to researchers and teachers collaborating. So here's an example. I would like to redesign this explanation to become one of these adaptive intelligent microlabs. So the context here is on a problem page in edX or any website. You might give people a math problem, and they type in answers, see if it's right or wrong, and they might actually give them an explanation. Well, here's why that answer is correct. Right now, in most websites, there's just one explanation people get. It's one size fits all, doesn't matter who you are, and it's also relatively static. It's so expensive to just produce these explanations. People don't often go in and try new versions. And if you wanted to try new versions, you'd probably end up just building a new problem, which they have complained about, rather than just seamlessly adding in a second one that could then be tested out and see if the new explanation is actually better than the old one. So here's actually what the perfect ideal situation looks like. Well, let's turn that tiny component, that explanation, into a micro lab. Let's actually allow anyone here to write different versions of that explanation and pipe them in so that now these different versions could be delivered. So here's what a MOOClet does. It basically says, here's what this framework does. It says, take the component of a course and designate it as one of these micro labs where someone can see what's there now. Anyone can easily author different versions and put them into the system. There's a set of data associated with that MOOClet. It's data about users like what their pre-test score was, what their motivation level was, and also it's data about how they do after receiving these different explanations. And also there's actually a policy. So in a simple, clear way, you can specify are we going to experiment with these where they're equally presented? Is the instructors one represented 90% of the time or 10%? Are we going to personalize them so that someone with a low pre-test score gets this explanation? But if you have a high pre-test score, you get that one. This is basically policy. And what's really key about a MOOClet is that it's all able to adapt dynamically. When I used to run experiments, like the one on first one I ran in Stanford's Open edX, we said, okay, we're going to have 2 versions of these. We're going to launch them. We're going to assign people equally, and then after a year, we can see how they worked. Then we could put another version back in. But what's really key is that you can add these conditions at any point. So instead, if I knew what I did, if I knew then what I did now, I'd launch with 2. Someone would give me a better idea. I just added that in. Then I just added another one. So the idea is that it's dynamic experimentation. Another thing is that the policy allows you to change what's being presented. So again, traditionally, we always assign people with equal probability conditions, 30%, 30%, 30%. But there are a lot of issues now about ethical experimentation. That's challenging for teachers because they might say, well, what you're saying to me is you're going to just test this out on my student without any regard for what's actually helping them. Why is this helping my students? Well, what a dynamic policy allows you to do is do experimentation in a way that's more ethical. In the sense that, let's say we're assigning these equally, because ahead of time we don't know which one's going to be better. Well, a teacher might say, I think this is a really good explanation. So what this policy would say, allow you to say, okay, let's give this to 60% of students, and just give these to 20% and 20%. So the teacher can feel more comfortable now that we're at least starting with what we a priori believe to be helpful. Now, maybe teachers right, maybe they're wrong. We can actually use this data that's available in real time. So every time someone gets an explanation, we get data about whether it actually helped or not, whether they rated it. And then you can actually change the policy. So if the teacher's right, let's start off, the first 100 people present to 60%. But after we have 100 people, let's actually start presenting to 70%, 80%, 90%. If the teacher's wrong, of course, you could post another explanation. But the kind of key idea here is that having a dynamic policy brings together three different things. One is normal instruction, where we just have one version of something. That's basically achieved by saying, let's present this 100% of the time and these 0%. We get experimentation, where we can actually say, let's present multiple versions with different probabilities to see what works. And then actually, the third thing we get is personalization. So is it clear from what I've said so far how you can imagine achieving personalization by using a dynamic policy? So the way you would do this is, again, just change your policy from saying, let's present this at 30, 30, 50 to say, if your pretest score is below 50, then you get this 80% of the time, 10%, 10%. If your pretest score is above 50, well then actually you get this one 50% of the time, that's 70, this is not at all. So the kind of key idea here is that having this dynamic policy brings together a lot of things you all care about. Final instruction, testing things out and actually personalizing. What's especially important here is that this actually gives us a way to discover how to personalize, because it's incredibly difficult to know ahead of time how we should actually personalize and adapt it. Yes?
So I was going to save this for a little later, but let me just give you my take on this. Okay, so I run assessments. I get 50,000 kids. I have teachers writing explanations for math problems. Right? Why should I actually take my explanation that I think is the best and only give that to everybody? If we could actually, by the way, one of the key things that we didn't really mention so far is what is the reinforcement signal? What is the thing we're learning? In my case, if they're doing their math problems, we actually know how they do on the next problem is the independent measure that we care about. Right. And so if we actually have a bunch of different teacher explanations that we're comparing, we actually want to smoothly start to recognize that one teacher's explanation kind of stinks and should be given to nobody. Someone else's should be really given for, like, say, low knowledge kids, and someone else, the third explanation should be given to somebody else. And so that's why I'm excited about actually just the framework, because it gives us a way of thinking about how to do that in a sort of elegant manner.
Yeah, thanks for answering that, Neil. Here I was actually thinking about more in terms of what you could do, but Neil makes a great point. The key thing about a flexible policy is you might start off thinking, well, I want to choose explanations so that students rate them really highly. But then actually over time I'd say, well, actually, I prefer to choose explanations so that they help students solve the next problem in assessments. Or if you instruct, you might say, that's okay for now, but every week I get their quiz scores. I really want to choose explanations that maximize what their quiz is at the end of the week. That's what I really care about. So this actually, as we pointed out, lets you adjust this policy, even as you yourself change your decisions about what you think you should be optimizing for. Oops. Okay. I just talked about one example, but actually you can imagine doing this with different videos. So present different videos and see which ones of them maximize viewing time or maximize learning. You could think about it for content on a web page. Let me use this fancy laser thing. Okay, nice. You can use this for content on a web page, because as you imagine, as this was being developed, I'm pretty sure that the instructor had different ideas about what they could have said, and maybe a teaching assistant or another instructor could have suggested alternatives. Now you can actually put these in. Email actually is one of the first studies that I ran with Justin and Jake Whitehill and a few other people, where we made one of these emails actually an adaptive MOOClet, where what we were trying to do was optimize how many people would actually give us feedback about a course. And we did it by actually writing different versions of subject lines, and then actually discovering which subject lines were effective for different age groups and people who had different levels of activity in the course. So as you can see, I call it a MOOClet, but really that's just to communicate this idea that it's a specific formalism. You know, when you've designed something as it, you can apply it to any piece of technology. Okay, so I'm going to go through this very quickly, just to technical people who would really care about this. What is the formalism for MOOClet? What are the if and only if statements that have been satisfied? Well, a MOOClet is any technology component, a lesson, an exercise, an email that meets these criteria. For example, this is actually what is in, sorry, I found your name very hard to pronounce. Could you say your name again, your full name?
Zofia Gatos.
Sophia, not Sophia, Sophia Gatos. So in the course that she's working on now, biochem, we actually added questions to get people to reflect. So what made these MOOClets? Well, these questions could allow multiple versions to be created. I mean, that's pretty trivial, but what I mean more here is that anyone could just type these into a spreadsheet and they get deployed into it. These multiple versions can be presented using if-then rules. So you can simply write, well, if someone has low knowledge or high, then present version 1 or 2. And these if-then rules are based in our policy. That's where you write them. They are based on a modifiable list of data and variables linked each student. So these could be things like what Neil mentioned, which is the target outcome variable, like next problem right, or they could be individual differences like level of knowledge or what they did last week. That's what I call here the user variable store. And then finally, what's really key is that both the rules in the policy and the variables can be dynamically changed at any point. So you basically deploy a system where it's flexible in the sense that you may not know exactly what you want to do in the end because education is that complex, but you can actually modify it dynamically. If you do these things, basically, you have a MOOClet. And one thing actually, which is almost really a sad thing, is that I did so many experiments where I just implemented it as sort of a part MOOClet, a crippled MOOClet. And all of A/B testing is basically crippled MOOClets because it's implemented in a way that you can't dynamically move to personalize. And I did this for years. But once I've seen this now, I easily go back and re-implement my technology. So anytime you want to do an experiment, if you do as a MOOClet, it gives you added flexibility because you can change how often people get conditions. And if you discover a way to personalize, you can roll that into it in real time. Okay, so here's some examples of things I've implemented in MOOClet, and that's a link to just a demo course I built in Edge, so you can actually see it. I just use Quadrix. You can use any kind of programming language. Quadrix is free for every one of you. You have an account, even if you don't know it. So pre-course survey, where Justin and others have run a huge number of experiments. You can make portions of a pre-course survey, like which questions you ask people to reflect on into MOOClets. And that's what I've done there. You can make lessons. Any web page, any piece of a web page could be a MOOClet. You can make problems. So do you want to add some motivational messages or some hints or some explanations? And you can actually make emails. Emails, the digital equivalent of talking to your students. So anything that you might imagine in a classroom, you want to personalize or you want to test out different ways of saying something, you can do that through email. Okay, so here's one example application of how we've used MOOClets to do something that I think was a step forward. So I'm going to talk about basically taking a core component of MOOCs, of a system, of any actually STEM instruction, which is the explanations that show up in problems. So a lot of problems on edX, for example, right now, or Coursera, NovoEd, they give you a problem to solve and they can tell you if the answer is right or wrong, but they don't necessarily have very comprehensive explanations afterwards. So our idea was, well, let's actually build a prototype system that would actually allow you to give explanations to people using a MOOClet. So we could start off with nothing at all or just one or two and keep adding them in and see what worked. So what does this kind of buy us if we turn that thing into a MOOClet? Well, one thing it buys us is actually, at least the way we implement it, is interface for explanations. So let's say that we're applying this to a physics course. Right now, you probably have tons of problems like that. Well, what we did is we implemented this piece of edX so that there was actually an interface in a Google spreadsheet. So Dave Pritchard could type the first explanation. Safe could type the second. Any of you could type the third or fourth. Those would then be piped in real time into that MOOClet. So you actually type in a Google spreadsheet, and I have some I can open up right there, and the system actually pulls that data in. Another thing it does is it gives you an interface or view onto the data that's associated with each user. This is really important for instructors and researchers. As an instructor, you would like to know, what can a researcher see about my students? What do I want to give them access to? As a researcher, you don't want to run an experiment that lets you know, well, what data is going to be made available to me and when is it? I think anyone who's worked intimately with online platforms already knows this is a problem. But if you're not familiar with it, I would say it's very easy to look at a platform and assume data is going to come. It took a year to get data from Khan Academy. even though they're extremely helpful and very competent engineering-wise, one of the heroic things Justin Reich and Andrew Ho and everyone did last year was basically get edX data into databases where we can understand it. Once you implement something as a MOOClet, well, actually, each of these is a subject, a person, a learner. Every time they hit the MOOClet, that's when this data gets updated. So again, imagine a Google spreadsheet. You're actually seeing, what was their rating for how familiar they were with the problem, which explanation did they receive, how did they rate it, did they get the next problem right or wrong. So you can actually get this data in real time, either from the MOOClet itself or from other data sources that you can pipe in. And this is the user variable store. As an instructor, you can then say, well, here are these 200 variables. I don't want researchers 3, 4, and 5 to have access to student names. Researcher 7 can have first names. So you can actually then know exactly what data is going to researchers. As a researcher, you actually feel very comfortable now because you know exactly what data is coming in. You know how it's distributed, you know what's being made available. That can actually allow you to design a better, more practical experiment. And now in terms of the policies, so this I think is really the critical part. It's as easy to specify a probability as, again, typing into a Google spreadsheet. So here's what every class experiment looks like. 50% get explanation 1, 50% get explanation 2. In both edX and SysMods, which are pretty sophisticated in terms of doing research, right? You can't specify these probabilities. You basically, whenever someone sees an explanation, as many explanations as there are, they just get randomly assigned to one of those. So if you have 2, you've got to put everyone in 50% condition. You can't really say, well, 10% here, 90% there. Another thing you can't do is, if you decide, well, I'm done with explanation 2, let's just give explanation 1 all the time, you have to go in and basically just destroy that component and replace it with a new one. If you change your mind and say, hey, look, someone gave me a new great idea for an explanation, you have to go and destroy what you just did and put back in the naked text and add them in. Instead, once you've implemented this in MOOClet, it lets you change policy without any code, any action, just by basically flipping numbers. So here's an example of a dynamic experiment where we might start off giving people explanations 50% time. But then actually, we find, well, explanation 1 is increasing their success next problem. So let's give the 65% people 35%. You could just go and modify these numbers as you like. What that means is that algorithms, or you can use API to do it as well. So to be more sophisticated, you can actually then move from experimentation straight to personalization. So let's say that as you were doing this, you discovered, well, explanation 1 is better on average for getting the next problem correct. But you know what I'm noticing? Explanation 1 is actually really helping learners who have a low pretest score. Explanation 2 is not so much. But explanation 1 is actually not as good for high knowledge learners as explanation 2. So what you could then do, once you analyze your data from this in real time, is you could actually then basically go and modify the policy. Write these if-then rules that will then actually allow you to personalization.
Would you ever write explanations that address misconceptions if you notice what people being done wrong?
You could certainly do that. We haven't done that yet, but I think that would be a great future direction. Basically, this is what's unusual about this presentation is I'm not presenting empirical result, but really truly, this is human-computer interaction research. I'm building technology for certain users. These users aren't just the students. These users are the instructors and researchers. So you could actually use this framework to do all kinds of things. Exactly like you said, you could say, I'd like to actually do an if statement that says, if they said multiple choice answer C to problem 5, then I know they've got a misconception, where they think that area is the same thing as volume. I'm gonna write an explanation for them, make an explanation 3. I'm just gonna put a rule in that will present that to them so they actually target their misconceptions.
The grant I was referring to, we had teachers in Texas yesterday, and pre-service teachers writing actually their attempts for their misconception messages to kids. So we can try to figure out which of those are most effective, which ones are a little longer, which ones are motivating. So yeah.
It looks like you can see concretely. So this is how we go from something that could be a sort of opaque wall, defining a component that becomes a micro lab that's adaptive, and actually allows us to add new versions, see data in real time, and then actually change our policies. I'm going to say something, again, that's very technical, so I'll pick you up on the next slide if it's not clear. But basically, what's really key about this is that a big part of my background in my PhD was actually designing computational models for how people learn. So actually using statistical machine learning, algorithms of computer science for analyzing data to modeling how people learn. Now, I've actually designed this so that anyone who does machine learning, big data kind of work could actually apply their algorithms through real-time experimentation and personalization. They can use algorithms to discover how to personalize. And they don't have to know anything except that it's a MOOClet. We organized a workshop at NIPS, which is this December. If anyone's interested, it would be great to have you join in Montreal. But basically, it's all about showing these researchers that they can actually run their algorithms in the real world every time a new data point comes in. So when I gave a talk on this at another machine learning conference, ICML, they were actually really amazed to know that they could actually plug the algorithm in. Because one of the biggest challenges is that a lot of machine learning and statistics analyzes data after it's been collected. You can only see, it's almost like a post-mortem. This actually allows them to play a role in saying, well, as you present these explanations, present them in this way to these learners. They can actually now use algorithms to help us guide data collection. And for the technical ones, practically, I was very much saying why machine learning researchers care. It's good for us as instructors or even as just experimental researchers because basically we have these thousands of people who do physical algorithm development who now want to help us automate instruction. So the idea here is that these things I showed you before, where normally you write in by hand, you can actually get these people pretty much for free because you're letting them test the algorithm in the real world. Writing algorithms will automatically update those policies. So it's a way to do automated experimentation and to automatically discover how to personalize. You don't lose control because you see at every point what's going on. So again, it's trying to trade off instructors' concerns with scientists and machine learning. Just for people who are technical, basically, it matches the outline of the basic reinforcement learning model, where any reinforcement agent has a set of environment states, a set of actions, rules to determine what the reward is from being in a particular state. And so you can think of the state space or observed variables as basically combinations of user characteristics. So it's like the agent or this explanation, MOOClet, says, well, here's a user of age 25, they got the last 3 problems right, their motivation is low, according to a pre-course survey question. What do I do for that? That data comes from the user variable store. The action space now is the alternative MOOClet versions. So you know its explanations, but really all someone else knows is that they could deliver these different MOOClets. The reward function is actually what you're trying to optimize, like Neil brought up earlier. And this actually allows the instructor to play a big role. They could say, well, if I'm presenting explanations using whatever your fancy algorithm is, here's what I want you to optimize for me. I want you to optimize how people spend the page. Or maybe I want you to optimize that and the probability that I get the next problem correct. Well, actually, you know what? I'd like you to optimize final grade in the course. Now, it's not that likely that what explanation you present on one page will optimize final grade in the course. So they'd actually probably have to optimize that by trying to do something more local, but you could at least specify these as what you want. And of course, now the key thing is the policy. This is what the algorithms are setting, are basically which actions you take for any particular user. Okay, so picking up on the next slide, basically it lets you get machine learning people to automate experimentation and personalization for you. And these are particular models you can apply: multi-arm architectural bandits, MDPs, POMDPs, and really anything that's reinforcement learning. So here's the application I looked at. It's actually helping learners get good explanations, like an example I showed you before. And this is inspired by looking at some work in assessments, but also in edX, where often in these MOOCs, we don't really have that many explanations to give learners. If you've seen a problem, maybe not Dave Pritchard and Steve's classes, but in many MOOCs, you solve a problem, and you get told the answers right or wrong. Maybe you get like a one-line explanation, but you don't get a good explanation of why is that the right answer. So how could we actually use MOOClets and sort of theory from psychology and human interaction to design interfaces that would actually create explanations and see which ones worked? So the competition problem we have is let's optimize explanations by automatically experimenting. Let's get a bunch of explanations and just present them, and then learn through these machine learning algorithms what works. The design problem, though, from the perspective of the instructor or from a human interaction perspective, is how do we help learners? Like actually not impose on them to just write explanations for us. How do we actually help them learn, and in the course of that, get some useful output that we can use for getting good explanations? So this is the name of the system we built, Adaptive Explanation Improvement System, ACCESS. And we've applied it in one specific context, but really, if there's any bit of text, any explanation that you want to send an email on a web page, you could actually plug the system in very easily. I can actually share the spreadsheet and sort of object that was used for it. It's pretty straightforward. Okay. And so looking at time, I think I'm going to actually skip through this pretty quickly, but I'd be happy to take questions after and let Neil go on. Basically, what we did is, if you remember that image I showed you before where people get explanations after solving math problems, we'd actually ask someone to rate before they solve the problem. How well do you think you can solve problems like this on a scale from 1 to 10? Then we give them a problem. So here's a math problem, and what I did is I actually worked with someone on Neil's team in Assist Months to basically choose 4 different math problems that they thought they'd like to get explanations for, like good explanations. Then we give someone an explanation of, so someone gets the problem, they attempt it, they write the answer, they get told the right answer. Then we give them the explanation. We ask them to give it a rating. And the idea here is that it's making sure that they themselves are processing and learning about it, but at the same time it's giving us data so we can actually try and optimize which explanations get the highest ratings. Then we actually draw on work from cognitive science education that even though we normally give people explanations, there's hundreds of papers that show, and this is what my dissertation focused on, that actually prompting someone to explain in their words can actually help them learn more. So we've actually shown in other work that if I ask you to explain why your answer is correct, even if I don't tell you if the explanation is right or wrong, even if I don't show you a good one, just having you explain, well, why is that right? It actually helps you learn. It lets you see what gaps in knowledge are, and lets you construct the underlying principle. And so that actually can sometimes be better than giving you an explanation. So this is again something where we're helping learners to reflect and think, but at the same time, you can guess what we're doing with those explanations.
Your explanation isn't actually explaining.
Yeah, I just put something in. The actual one was too long.
Okay.
Yeah. You have really good eyesight. Yeah, that's like the first line of the explanation. But you have way better eyesight than most people do.
I have very good eyesight.
So that's the first line of the
I
explanation.
was just like, that's not going to be a highly rated explanation. It's not helpful.
Yeah, but I have to tell you, some of them do look like this because when they just write all kinds of things, you know? But yeah, no, absolutely. So that's actually,
I guess by the way, we often actually don't just want explanations. We want hints, right? Just little bits, right? And so figuring out what little bits is maybe actually more useful than full-bore explanations.
You know, one of my favorite projects that hasn't continued was actually a crowdsourced hinting, where people that would get a wrong answer would actually enter the hint, like after they got the right answer, they entered the hint. This was in edX a long time ago.
Oh, really?
About like what helped them realize their mistake. And then other people who entered the same incorrect answer would be given that hint.
Is this Piotr did this or someone else? I would love
It was for Simona Socrates 201X.
I would love actually to, if you don't mind putting me in touch with Christian, that would be great to see what they did and what data they got.
Yeah, I mean, it was really popular, and it's actually really sad that it never became anything, because this was at the very first year that it happened, and it has not existed since then.
Okay, well, we'll bring it back. Okay, thanks a lot for that.
I think Joseph's not aware, I'm not aware, I've seen one write-up by Piotr, it's just 4 pages long, that actually talks about this a little bit.
I don't think anybody's really talked about it. The woman that runs the course is not like super into writing things.
But clearly what we actually really want in this sort of crowdsourcing world or learner sourcing is to complete the whole loop, meaning actually being able to demonstrate that the people participating are benefiting while also the people that are consuming are benefiting.
Well, and I think the thing that was, that would make it really also a good thing to combine with this is that the faculty member was actually reviewing all the hints herself.
Yeah.
And that's what made it difficult, is that she had to go through them and like get rid of the garbage, make sure people weren't actually putting the answer in the hints, you know, and all that sort of stuff. To then like make sure that only reasonable and not cheating hints were allowed.
So I think you would like the system because that's absolutely where you want to go next. But what the system does actually is like a plug and play. The faculty teacher doesn't do anything. The work is all done by other learners. And the way we were able to achieve that was actually by using the sort of psychological theory I mentioned in designing it, and also by using machine learning. So okay, that would be great to check out. I think the insight is a great one.
Well, I just think it's also a really nice way of combining this idea of explaining in your own words with something that could then be crowdsourcing all of this information for other people.
Yeah, no,
And
that's great.
supposedly it exists already.
Yeah. Well, I mean, it's pretty easy to build. Like, I would actually just be interested in seeing what they did, how it worked, and then I just rebuild it. Because this, I mean, I could build this in maybe 30 minutes. If you told me you wanted hints in your classroom right now, I think 30 minutes max to build a system. Getting it to work, of course, is where the real work comes in. So basically, as I said, so we prompt them to explain, and then these explanations can get piped back into the system. So I'm going to skip over a bunch of details here, but basically, we've got a sort of learning policy. So we've got a pool of explanations that get piped in, and then we actually start off by just randomly assigning people to all of them, and then we actually learn based on which ratings are effective, which ones to present more often. As I mentioned, there's this abstract reinforcement learning. Because we actually use these MOOClets, we're able to plug in an algorithm that actually was multi-arm banded. We didn't use information to try and virtualize it here. Just as a first step, we assumed that those differences wouldn't make a big difference. So we just tried to maximize the ratings of explanations. And this algorithm was so simple, we actually implemented it in a Google spreadsheet. So the nice thing about this is it's very scaled in the sense that I could clone a Google spreadsheet and give it to you, and you could be running this like within a couple of days in your own course. I'm going to skip over the different algorithms you could have used. We used something called Thompson sampling. And basically, our policy, our algorithm, tried to maximize ratings of explanation. The actions were which explanation was presented. The reward function was rating of how helpful an explanation was for learning. We didn't use any context or state space. The action space were different explanations. And the policy now was start with Thompson sampling, where we started very optimistic prior beliefs about what the average rating would be for an explanation. So we used beta priors, beta distributions. And these were sort of optimistic, expecting that an explanation would have a 9.5. But it'd be very weak. We'd pretty much say we have that expectation for each explanation because it's as if we have fictional prior observations that we saw one explanation rated 9, one explanation rated 10. For people who do machine learning, we basically use conjugate priors here. And then actually we converted the rating that it actually got from 1 to 10 to basically, like if it was an 8 rating, 8 successes, and then 10 minus 8, 2 failures. That was just technical information, but let me pick you back up. Basically, the summary of all this is we implement the algorithm to look at everyone's rating of an explanation, try and maximize, choose the explanations more frequently if they were highly rated, and if there was good evidence. So 100 people highly rated versus 10. So the deployment was actually just with 150 people, because we really wanted to see, could this work at all, even with just a typical size of a classroom? Can we do it without needing 1,000 learners? Then actually, we ran the algorithm change policy. The evaluation, though, was a lot more intensive. We then took the output of this algorithm and the system and ran on a separate batch of 500 people, where we presented all the explanations that came out of learners, good and bad, and then we collected their ratings of if they perceived gains in their learning. We actually measured if they did increase in accuracy from initial items to later ones. And the kind of key thing here was the conditions we compared were sort of the baseline where people just got problems. They attempted it, got answers and feedback, but didn't have explanations. We compared that to problems that actually did have these explanations inserted. These explanations that were crowdsourced from learners themselves writing. We also compared that to actually an instructor's explanation. So on assessments, what's right now going out to thousands of learners? We don't, I mean, we'd expect learners to be a lot less good, like less highly rated and actually have less of an accuracy increase. But the mere fact that you can develop them so much more cheaply would be a big win. Because our use case here is not if you've already got a good explanation. It's if you have no explanation at all, how do we generate them from scratch? So basically, if we look at someone's rating before they solve a problem, how well can you solve problems like this on a scale from 1 to 10? And we look at it after the problem. Here I'm comparing if you were just solving problems to if you got problems with some explanations that were chosen by the system. In this case, we're showing you the explanations that the system presented as best. We're basically taking a weighted average of explanations. So all explanations, ratings, but weighted by the policy that says, here's the probability of presenting explanation 1, 2, or 3. So it's like a weighted average. So that it significantly increased people's ratings of how much they thought they'd learned from a problem. So if they were just practicing, people didn't really feel like they were learning from just practicing, which is often what people are doing online, but providing explanations did actually provide a boost. Now this is really useful. This is often the best proxy you have in many online environments, but as a psychologist, what I'd really like to know, as an education researcher, what did it actually help them increase the accuracy of solving problems? So here we have an explanation. Those explanations were added to problems that just came from a learner. They were just writing this thing and it wasn't filtered by Access's algorithm. That actually doesn't impact accuracy. Here's actually effective giving them the explanations from Access. Actually, that results in a small, Access is small, but pretty small, but still reliable, 10% gain in accuracy. Which is, 10 to 15%. That was actually comparable to the instructor gain in accuracy. Those don't differ significantly. And it was significantly more than if they just were practicing problems. So basically, we deployed the system. It was actually able to run without any instructor intervention. And what it output was actually made the learners perceived as useful and actually did increase their success in solving problems. Of course, the main contribution I want to stress is actually the approach and the methodology and how you can use it in other situations. Here's just one concrete use case. I would hope that using the system, all of you could actually produce much better results than we have so far, and we will actually, in 6 months or a year, have really doubled up on this. I think I'm going to switch over to Neil, but basically, what we did for machine learning algorithm was move from experimentation to what you might think of as partial personalization, where we changed the problem getting condition in proportion to how much it was helping learning. Just to remind you, I've talked about one MOOClet, an explanation, but it's really like a one-to-end buffet solution. If all you're going to do is just put one explanation in, that's fine. But if you put different motivation strategies, emails, videos, then all of that data feeds into that user variable store. So it gives you rich information and it gives you more levels with which to actually impact learning. So try and optimize people's outcomes. With research testbed, for example, does pre-process a lesson problem, and this actually gives you a pretty rich data set in terms of what people's goals are in the course, different versions of lesson they get, how long they spend on it, whether they get problems correct or not, which versions of email they receive. And again, it really makes it easier for instructors and researchers to collaborate on designing these experiments. As I mentioned, any A/B experiment, now I don't run experiments that aren't implemented as MOOClets. Because if I'm not actually going to do this dynamic personalization, it's not that much harder to just implement it that right way. And then it actually leaves open the idea that I can start off with equal assignment and then transition to the best condition. Or I might discover an interesting way to personalize and I can actually put that into the system. So anything in edX, maybe 45 minutes means that you're probably long if you do it on your own. Any LTI component. So if you don't know what LTI, then technology interoperability is, it's really one of the most fantastic things for allowing any learning systems to talk to each other. For example, in Canvas, you can either adapt TLT's open source tool or just use portions via LTI. I built a tool for it. In Moodle, in MoveWed, and in 6 months, we're now gearing up to launch. At which point, I'm going to turn it over to Neil.
Great. So I'll keep it short because I recognize the time. So let me say maybe 2 points. One is actually, there's this cyber infrastructure grant that actually has funded us to actually help external researchers conduct studies. It's at assistance.testbed.org. And will you go there for me?
Sure.
And so the assistance.testbed.org. So we actually let external researchers conduct studies. At the moment, we're not actually doing the MOOClet thing. If we're doing the MOOClet thing, like if they actually were to take their experimental condition that they think may be worth putting up against our current best conditions. And most of our external researchers, they usually actually have like 2 conditions they want to compare. That differ by a single factor. In which case, from the assessment's perspective, because I run this assessment site that's got a few thousand kids actually using it, or I guess 50,000 kids a year, and so I actually want to see if their things are better than whatever we currently have. But they also often care about actually the little variable that they have manipulated. Oh, whether it's text or video or it's whatever it is, because they want to go publish on that. I'm happy with that, but actually but if both of their conditions lose to our existing stuff, then we're going to turn it off smoothly. This MOOClet framework actually gives us a way of actually turning it off smoothly. And I like that. And I guess where I think actually this MOOClet framework stuff really comes to bear is when you actually are thinking about the crowdsourcing. So we're now actually letting teachers make these little video explanations. We literally have tens of thousands of experiments happening simultaneously. There's no one person that wants to actually understand each of those little things, right? I have like 50,000 problems in our site. And so let's say we have 10 explanations per thing. There's hundreds of experiments. So interestingly, there's also cool methodology things that I was just publishing upon our own scale about actually when you're actually analyzing 20 experiments at the same time, what can you do better? There's really kind of interesting, cool things you can do. And so, anyways, I think we should throw it open for questions. So, questions?
Yeah, I mean, I can really see that there is potential application for this in the introduction of Common Core, where problem solving right on this Common Core test is not just what we used to think of as problem solving an answer, right? That you need an explanation. So, so this whole concept, right, of the importance of the explanation as part of the test and what students are being assessed on. Are you connecting these things?
Yeah, so basically, we're building out right now what we call the peer assistance framework, which is kind of like where we're going here. My graduate student, Doug Salent, is actually making it so that his kids actually write explanations as part of their normal math problem solving. There's some normal math problem solving happening there on the screen, but at the moment we're not actually collecting their explanation. But can we're architecting this so that actually we can let we can let actually these kids write these explanations, and then the control of their teacher to turn this on and allow, I want to actually let kids actually see each other's explanations in controlled manners. I say controlled manners because, like, in one sense, these explanations, you could think of them as there's some big, actually, discussion board where kids are posting stuff. Essentially, what I'm doing is I'm actually not making a discussion board. I'm deciding that only when you actually say you can't solve this and you need some help, do you get to see this. And that way, their teachers know, Johnny couldn't solve this problem by himself, and then he actually got some assistance. I actually want to actually use how do they do on subsequent problems as the dependent measure, so we can actually evaluate which explanations are good. We also actually have to worry about actually helping teachers know how to do this well and actually feel that they actually control this too. So as I run assessments, I have to worry about sexual predators actually writing explanations. And so how do we actually, because anyone can go in and make an account inside assessment, so we actually have to lock this down in ways that only kids in your class can you see their explanations. We also need to make it such that the instructors understand. The instructors don't understand, they're going to buy into this, and they're going to actually like it, they'll actually want to not do it, right? And so, but plenty of teachers want to actually get kids explaining stuff, and maybe a graceful thing. So, well, we have to design this right? We actually can't actually be oblivious to some of the Does that make sense?
Yeah, I'm just thinking, for classrooms going forward, this is not, the explanation part is not an optional extra. But it is going to be, part of the core, right, that students are tested on. So from the point of view of students' errors, they're going to go berserk It's a kid's market.
Yeah.
And- Did you have a follow-up point?
I think just in terms of the explanations, I think it's also really important for it not just be purely text-based and it allows other students to draw things, because I think usually, images are hugely important in explaining things, like occasions are hugely important in explaining things, especially maybe at the higher levels, maybe not. Actually, even at the lower levels, pictures, these are all really important, and I think that to me is a really interesting space of how do we get these really robust explanations, which are really the things we want to look
Yeah, that's why actually my team of undergraduates and graduate students on the mobile app team, so we have an assistant app course for Android and iOS, and we're starting there because actually we want to actually make it easy. Which is basically we want to make it easy when a teacher says, oh, I'm going to assign this Pythagorean theorem problem set. Well, would you like to customize it with a 20-second video? We'll give you a hard problem that your kids are going to see. And that way, they also see that you're in it, right? There's also, like, how do we design this such that actually, because I don't run a MOOC, I run actually a tool. Okay? My son calls it a MOOC, massively online tool. Teachers decide to use my tool. We can actually make it feel like actually these teachers have actually put in some effort to write an explanation, and we want to make sure those explanations can get seen by their kids, so they kind of feel like, oh, my teacher bought into this. This is not some random kitchen product. She says, oh, go off and do some stuff. And so it seems like to me like the hard part of this work is designing this so that actually the various participants, be they teachers producing stuff, but also kids producing stuff, should. Getting that design right is actually important.
So, and that's actually my question. You said all the explanations just go in Google Sheet, but like, what's the format? Does it have to be plain text? Can you have LaTeX in it? Can you?
Right now it's just plain text, because that's a prototype system. But I think what you're saying is actually a good point, and so many teachers have requested.
Because I can just say like, I love the idea of this, but I could, first of all, I don't have enough time to make multiple explanations for things yet, but almost all my explanations have images and animations.
Yeah, no, that's true. I think one thing I would say is, that's absolutely the best way to go. I would say this is actually just a cost-benefit question.
Yeah.
Which
No,
is,
absolutely.
yeah.
I spent make a lot of it.
Well, also the truth is that you have to build a tool to let students add those things in. You have to train them to use that tool. So then it's actually just a question, to what extent is it better to have a more sophisticated tool for writing explanations versus be able to empirically test simple text explanations?
Well, that I think it maybe depends on what the task is. Maybe there are certain tasks that lend themselves to very simple text explanations as being more of a reasonable thing to do, but then it's not worth my time to do that. And other explanations that, like, there's a deeper thing that I need to get across.
Well, I think I'm totally with you in that actually, where are we really going and why are we actually training pre-service teachers in Texas to actually do this? Because every pre-service teacher needs to be able to actually say, well, Susie, you just said 27. Here, blah, 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 blah. I'm going to tell you something right now. I should be able to do that instantly. Wow, that's what a good teacher actually is supposed to do. Right? And so that's why what we're doing is actually we're starting with the big, okay? Because basically the systems I've spent millions of actually or tax dollars actually writing are one text hint message with some little graphics, right? But actually what we really should be doing is figuring out how to actually crowdsource that and crowdsource a little video. So right now our Android app and our iOS app actually will take your explanation, pump it to YouTube, store it under the assistant's account. So we can do all the things you actually also want to do, which is also, I'll come back to the examples that actually I think are also important, that actually teachers need to be able to have full liability traces. So when it says, so when Chiefs flags actually Dave's actually answer, and then I go and look at it and actually see, oh, Dave actually used, actually a swear word in his explanation. I need to actually have a conversation with Dave.
Okay, why did you do that?
I'm picking on Dave because I know Dave. And I don't think I've ever heard him swear. But, but basically we need to support the complete workflow, which actually also includes teacher then flagging Dave's explanation for deletion in 30 days, but actually not immediately. Because I want it to be privately available so that actually I can talk to Dave and say, Dave, you need to bring your parents in here tomorrow, okay? And so we can show them this, right? Like, that part of the explanation stuff in my world is really important.
And just as we close off, one thing I just want to share is we've actually through this grant actually built into us this month the ability to actually be embedded inside of edX. So really, where I think Neil's pretty interested in actually seeing, you know, embed edX via LTI. How can we actually integrate these two platforms, especially as one is K-12 and one is higher ed? And another thing is that you could actually, the nice thing about this is Assessments is, like you said, a tool. So it's not like launching a whole course. You could basically just go in here and clone a math problem, and you can actually just start editing it. So you can actually go in as an instructor and use this for your, undergrads, right? So you can just go in here and like edit, add some text, add explanations. And as we MOOCletize this could basically be a way that you could actually just add different explanations, and then actually you could write the rules for personalizing it or get them adjusted with machine learning.
Right. So to be clear, Assessments allows you to actually go copy any problem, but we don't have open Wikipedia. Like, you can't go modify anybody else. You can't graffiti anybody else's content. But unfortunately, right now, like, I built it in a way that actually is very static. Those hints are hits, right? Like, you pick this. But what we really need to move towards is actually, essentially, would you like to actually use the assistant-created hints that actually people worked hard on? Or would you like to use your peer-generated actually feedback? I want our hints to lose, you know. Probably right now, our hints we spend a lot of time, and we get some thoughtful now with videos, and those of that teacher actually put effort in. But I bet we should be able to be deep. And the only question is how fast, how long does it take us, and how do we recognize when we lose?
And so I just want to close, and then we can take questions, or Justin cut us off. But since just giving a quick overview to close off everything, basically, I think the main point of this was saying, let's take online education source, a page in edX, and system problem, and turn it into one of these MOOClets. That makes it adaptive, and let's just do research. Gave some examples, which I think you can remember. Showed how it enables both experimentation and adaptive personalization, which could be automated through machine learning. One application, crowdsourcing explanations, and then we'll talk about how this approach is actually being applied inside of systems for crowdsourcing. And future direction is up to everyone here. Sorry, Dave, do you want to throw out your question?
Start 10 minutes.
Ah, okay.
Okay, don't use any swear words.
So I actually had a question.
Yes.
In terms of personalization, would it be possible to use this to, say, if I was a woman in a computer science course, to get word problems that had words like Mary and Jennifer and
Yes.
things like that?
Yeah, it would be pretty straightforward. And there's actually some research looking at things like that, but they've sort of run studies, but they haven't implemented it. It'd be very straightforward because that's a good text difference. And gender comes from edX even before you do a pre-course survey. You could also use it to send emails that are different for women and men.
I'd be interested in the results of emails. I never know. Of course, granted, I'm not going to write 3 different emails.
Well, I think the key thing is that, and this is something I realized in trying to bring together instructional researchers, if you get a psychologist to look at your email, they don't want to write 3 emails either, but what they're going to do is they're going to modularize it. They're just going to change 2 words in the subject line. So when we say different versions, really,
Not hugely different.
exactly. And in a way, you know, that's what the whole field of psychology is about, is like what are small changes you can make. But often the nice thing is, if you just, instead of having to know psychology, or put one in send an email to one, basically you can actually just kind of post and say, well, okay, here's my design, here's what you can change, here's the dates you get. And you can actually have a call, like a competition. Can people propose different versions of that? And then it really scopes the problem. So then they just change a few things, they pump them to you, and you just review them very quickly, and that can be launched.
So I think we should stop. I'm not running away. I'm happy to chat with people. I think it's always happy to talk about MOOClets. But why don't I thank you for your attention?
So next week with the holiday meeting, and the following week, Eric Taylor, professor from Harvard, will be giving a really cool talk about his research looking on the efficacy of adaptive learning, computer-assisted learning programs inside K-12 classrooms. Some interesting stuff about how strong teachers can actually differentially benefit from online learning, computer-assisted instruction. thanks guys for being here, and we'll see you next time.
Thanks a lot.
Ed Harris.
Eric
Eric Taylor.
Great talk.
Eric's
Okay,
coming.